Ready or one more minute? One more minute. Okay. Thank you, Timothy. No problem. Big one, Carla?
I don't know. That's fine.
Wow. It is pretty. Well, at least on the brochure. I'm not that. For sure, it's great. Well, I was thinking about college. If you're really on your game, you should soon, in the next week or two, go to your teachers that you want to ask for a letter of recommendation if you need it, and ask. They usually do them in the order in which they're asked. All right. And just so we're, again, while we're finishing, just so you're clear, it is an ask. So let's talk. Let's just kind of role play here. What's your name? Harrison. Okay, Harrison, you're coming up to me because I talked to you last year to ask for a letter of recommendation. Go.
Matt was out a letter of recommendation.
That's not that. Okay, I like it. I like it.
Mr. Richardson, I really enjoyed your class last year, and I would love to have a recommendation letter from you. Would you be willing to do that?
That's good. Would you be willing to? That's good. Okay. I'll give you an example of a bad ask. Would you be willing to is good. Don't say would you want to. Of course, would you want to do another 100 problems tonight for me? No, of course you would. And I don't want to drop 3 hours writing a letter of recommendation. So don't say would you want to. That's ridiculous. But would you be willing to? Yeah. I know how you guys sometimes ask each other, talk to each other like a non-ask, like you want. Anyways, it's an ask. It's not a commitment. Like you need to. I had a kid say, "You need to write your letter of recommendation." I don't need to do anything about. And you don't want the letter that now I'm going to write for you, so you best just block that out. It's an ask. It's not in my job requirement, and it almost all falls on junior teachers, which they are not super pleased about, but it's part of the job, and they understand that. But it's an ask, and just like you wouldn't want me to say, hey, your term paper's due November 4th, and you wouldn't want me to assign it November 3rd. They don't want one day to work on it, just like you wouldn't want one day to work on a term paper. So give them time, and please, and just, you don't need to give them a golden whatever as things. Just do stuff in afterwards when you know where you're going. Just kind of say, hey, thank you so much for writing me a letter. I'm going to Dartmouth. And that's so I know, because I write 50 letters, and I don't even know if you get in, if you not get in. I spend all this time. You can please say, hey, thanks, I got in. Okay, I just kind of want to know. So please do that, not before it's too late. Anyway, here we go. Back to math. Number 10a. Upon direct substitution, you get pi over 2 or over undefined. Does that mean it's undefined?
No.
Good job. Wow. Excellent participation. Instead, you should maybe go a little further. Pi over 2 is cool up top, but the bottom, I'm a visual person. Graphically speaking, what's at pi over 2? On the tangent graph. There's a vertical asymptote, okay? So the vertical asymptote, if we approach from the left, what do the y values approach? As x approaches pi over 2 from the left, the y values approach infinity. So we're dividing, I'm going to say it this way. We're dividing a finite number, pi over 2, by large positive numbers. What do we get when we do that? It approaches smaller and smaller, 0. The bigger the number you divide by, the smaller the outcomes you get, and so it approaches 0. Okay. Do you agree D and E would have been a false conclusion? Okay. What about when x approaches infinity or negative infinity instead of a number like pi over 2? What's the general process there? It's a different approach. End behavior. Okay, you talk what's called end behavior. As x gets negatively large. So how do we approach an end behavior problem? What's the mindset? Compared to what? Yeah. Yeah, who wins? Exactly. You look at who wins. You compare the dominant terms. Is it always the first terms you look at?
No.
Okay, it's not necessarily in descending order. So you need to look for the dominant terms. In this case, the dominant terms are there. Which one wins, the cube or the x? Cube. If overall x cubed over x is roughly x squared-ish, then as x goes to negative infinity, does x approach negative infinity or positive? Positive infinity. Okay. Question. Same basic question. Let's just call this 2 equals negative infinity. What do you know about A? This is a hard A. What do you know about it? Give me 2 things you know about it. Give me one. Even power. Why does it have to be an even power? You're absolutely right. Exactly. All right. So it's got to be an even power, so that afterwards it comes out after hacking away on x, we're left with naught. And what about how big A is? Must be, if the top is winning, it's got to be more than 1. So if you had choices, x equal 3, x equal 2, x equal 1, x equal negative 1, you would choose A, B, C, or D?
B.
Okay. All right. How about the next one? D and E or undefined is fine. It is, I prefer infinity here. I know there's a vertical asymptote going on, but to me it's more that it's different on both sides. You know, if it was from one side, I'd prefer infinity versus D and E, but I'd take E. How about this guy? Did this? I didn't, quite frankly, I didn't even try direct substitution. I just started factoring. What graphically is happening if there's a common 0 top and bottom? There's a hole. What's the calculus word for that? Removable discontinuity. Excellent. So if we remove that, then that hole is gone, or we don't care about the hole anymore. The limit's about the approach anyway, so what did you say? Okay. Which did you use? Both branches or just one of the branches? Just the first one or just the second one? If it's x approaching 0, do I look at 0 or do I look at everywhere else but 0? Yeah, limit is about the approach, and so as tempting as it is to say it's 7, and that is a major gotcha, it's actually 2. Right? Do you agree? Okay. Is this continuous? That's not a question, but is it continuous?
No.
It is. Okay. Give all asymptotes for y equals. So did you start by, what's the first thing you did? Factored it. Excellent. And is there an asymptote at x equals 0? No. Is there an asymptote at negative 1/2?
Yes.
So did you say asymptote at negative 1/2?
I said vertical asymptote at x equals.
Okay, beautiful. All right. You are an overachiever, dude. Negative 1/2 is not an asymptote, it's a number. Asymptotes are equations. Equations have equal signs in them and 2 sides. And so x equals negative 1/2 is it a vertical asymptote or a horizontal asymptote? Why is that? Isn't x horizontal? Yeah, it's where x is a problem. It's one instant where x is a problem. It is a vertical asymptote. Okay? By the way, I say VA, but that's not a real thing on a college. Don't say it's a VA at college. They won't know what you're talking about. Okay. Is that it then? Oh, there's another? Where? How do I find horizontal asymptotes? Yeah, look for end behavior for horizontal asymptotes. Must it have a horizontal asymptote, or it could have a horizontal asymptote? It could have a horizontal asymptote. It has a horizontal asymptote if, as x goes to infinity, the function approaches 0, only 0, or any constant? Any constant, including 0? Yes. Okay. And does it approach a constant? What constant? So negative 1/2 is a horizontal asymptote. Y equals negative 1/2 is a horizontal asymptote. Did you check x going to negative infinity? I didn't either. Can a graph have two different asymptotes on the right and the left? It can. Okay, it can. Now it's pretty uncommon. It's definitely not ever going to be the case for a polynomial. But if I did something like this, that has different on the outside. Okay. So to answer my own question, did you check both? I did. I didn't show it, but mentally I said, aha, you get me. All right. You should consider, what about the negative side? And the negative side, it would be the same, so don't sweat it. But in the future, do check. All right? Are we good on those? Boom, got 6 problems. I typically will do problems up for homework for a warm-up off yesterday's stuff, just to make sure you're good. Are you with me?
Yes.
Excellent. Would you go to the notes, which is the front of that page, please? The intermediate value theorem, or the IVT. There are 3 big existence theorems in calculus: the IVT, the MVT, and the EVT. All value theorems. This can be done with only knowledge of limits. The others you really need derivative knowledge. So we'll get to those later. All right. So this really is a common sensey kind of idea, and it's hard. The hard part is just how do I say it left. So I jump in an elevator, and I go from the 2nd floor to the 10th floor. Did I ever pass through this 5th floor?
Yes.
So I couldn't have gone straight from the 2nd floor to the 10th floor without passing through the 5th floor? I had to go through, I didn't necessarily open the doors and stop at the 5th floor, but is there any way to get from the 2nd floor in an elevator to the 10th without passing through the 5th? No, you got to pass through the 5th, right? And that's the intermediate value theorem, but it's got a bit of a gotcha when you talk more theoretical on a graph versus an elevator, which is a physical object. Imagine this. Say the graph went from this point. There's some graph that's kind of hidden here. I'm not showing it. But I am giving you 2 points on the graph. This graph, whatever it might look like, has the point 0, 4 and the point 4, 1. In going in those 2 points, must the graph pass through y equal 3? Does there have to be a place where the graph passes through y equals 3? Yes or no? Yes. Okay, well, I just set you up to fail because I just didn't get that elevator. Oh, okay. Why wouldn't it pass through y equals 3? Somebody who says no. Okay, there could be a hole. Is it possible there's a hole there? Is it possible the graph does this? And is it possible that the graph doesn't even exist in here and it's on the outsides? All those are possibilities, and so must there be a place where y equals 3? Not necessarily. The big question is it continuous? So that's one condition for this elevator theorem, or the IVT, to hold. It's got to be continuous. If it goes continuously from there to there, must it pass through 3? If the function's continuous at every point in between, must it pass through y equals 3? Yes, it must. Okay. If it's continuous, must there be a place where it passes through y equals 5?
Oh, wait, no.
Okay, what if it does this? Does it pass through y equals 5? Could it pass through y equals 5? But must it? No, okay. And you would say not necessarily, again, because 5 is not between 0, or not, sorry, between y equal 1 on the low end and y equal 4 on the high end. Right? So at the end of the day, the IBT has two conditions that need to be met in order for you to make a statement. And these problems are very much kind of a small mini proof or statement. The goal here is not to say, why is 5? It's not that kind of problem. It's more of a, this has to be the case because, and that's part of calculus. You make arguments in calculus, right? There are two parts to this. It has to be continuous, and it has to be between this. If the point they ask about is between two known points, and the function goes continuously between those two points, it has to pass through every y value in between. All right, now that's what this says, and I always will include the formal math definition as well as the common sense layman's terms. In layman's terms, if it moves continuously from one point to another, it has to pass through all the y values between. In fancy math terms, it says if f is continuous on a closed interval, then for any y value between the two endpoints, there must be a point in between the two endpoints where every y value is achieved. Let's see what a problem or two will look like, and then you'll try a few, and then you'll have a good feel for this. It's just the front of this, it won't take long, all right? Must there be a place where sine is 0.2 in 0 to pi over 2? Justify. Now, please write this down. The question does not say find the place. Okay? It doesn't say solve it. It's not the question, sine of x equals 0.2, solve. That's not the question. The question says, must there be a place where? And that is not a pick up your calculator and look at the graph kind of problem. It's more of a make an argument kind of thing, all right? Now, we're going to use the IVT to justify why there must be a case. First of all, does it meet the conditions for this whole thing to hold true? The first thing you're going to do is the function continuous? Now, by that I mean the sine function, which varies. This is constant. That's not an issue. The sine. Is sine continuous? Think graph. Yeah, it's got no issues, right? There's no asymptotes. There's no holes. For all reals, if you like. Right? Now the betweenness. Is the point they ask about between two known endpoints? Now that's where we need to find what are the, we're looking at the y value. Okay, I'm not looking for a place where x is 0.2. I'm looking for where sine of x or the y is 0.2. So I need to find what is the y value at the first endpoint. Sine of 0 is what? 0. So it's at the starting point, the y value is 0. At the ending point, sine of pi over 2 is 1. Graphically, think it went from 0 to 1. Must it have passed through 0.2? Now, you don't have to make a graph for this, but obviously, to do the proof, I'm just to instruction, all right? Must it have passed through 0.2? So you're telling me that 0.2 is between 0 and 1. You agree? Okay, we met the two conditions. This is a continuous function. It goes from one point to the other. And that point you ask about is between. It must therefore be the case that sine was equal to 0.2 at some point. This is the where you state the conclusion. By the IVT, there is an x in 0 to pi over 2 where sine of x equals 0.2. It's basically rephrasing the question with by IVT in front of it. Okay? There must be the case that sine passes through 0.2. Passes. Yeah, that's what the work should look like, and that's the hard part of this. Is what do I need to say? Questions? Okay. All right. Um, I will also say this. This math symbols were created to save you work. And so this is the most expedient way to do this. But if you were to write a long sentence saying, by the intermediate value theorem, because the function goes continuously from sine of x equals 0 to sine of x equals 0 or 1, it must do pass through point. All of that is exactly what that says, and it's accepted on my test, on the AP testing. If you're not quite sure what to say, just now, that means more reading for me and the AP grader, but it is what it is, okay? So if you're not quite sure, then that is acceptable, but symbols are quicker. All right, let's try another one. This is more of a common AP type question. Given select values of h of x below in the table, must there be an r, and that's an x equal r, that's an x value. Oh, yeah, okay, where x is between 2 and 5, or r is between 2 and 5, such that h at that point is 0. Now, in this case, they're not giving you a function, they're giving you a table of values. Does there have to be a place where h is 0? Look at the table. Yes? No? What smaller window besides 2 to 5? Give me a smaller window. 2 to 3. It has to happen in here because y is going from -7 to +3. Surely 0 is in between there. It has to pass through 0 in between, right? You with me? So let's go. We're going to state the conclusion. Again, it doesn't say find the r. You're not going to say r is about 2.3. That's not the question. Okay, the question is, must there be a place, and if so, why? So we're going to start by saying h is continuous. You don't have to say why that is, although why do you say h? It's given. Remember those geometry proofs you did? Given? That's given. Okay, h is continuous. All right. What's the next part? You have to show it's continuous, and you have to show the part they ask about is between, okay? H equals 0. Now, you say that again, you could say h equals 0 is between h at 2, which is -7, and h at 3, which is 3. But symbols are so much faster. Don't you agree that h equals 0 is between? Now, I can write -7 and 3 here, but when you refer to a table, it's a little clearer if you say h at 2, which is -7, and h at 3, which is 3. So that -7, where's it coming from? That 3, where's it coming from? It's clearer to the reader. So you're saying that, hey, that h equals 0 you ask about, it's between h at 2, which is -7, and h at 3, which is 3. If you wrote -7 is less than 0 is less than 3, that's acceptable, but on the AP test anyway, but a professor might think, cutting a little corner. Okay? All right. Now we conclude by IVT. There is an X or an R. What's the ask question? R. There is an R in 2 to 5, parentheses or brackets either way. Or you could say between 2 and 5. Where what? Where h at that r is 0. There's got to be a place where the y value, where the h of r value is. You with me? Okay. Try the first one, A. But if you did that fast, then you must be really good at this. Then start thinking about B, but we might have to talk about B. And feel free to talk to us about amigos. you to make bigger and bigger leaps. This requires you to start from the IVT and then extend a little, infer a little, make a little bit of a jump. But by the end of the school year, you're going to be able to make huge jumps from one to the other. It's going to be so awesome. Okay, this requires you to fill in some gaps in between. So the starting point to me was, all right, there's the issue of continuity. I'm not sure, I'll come to that in a second. But what about the betweenness? It says velocity is -2 and then velocity is 10, but they never say was the velocity equal to point. So it doesn't. So you have to start by making a connection. What are the two key words there to tell you what they're looking for? Find when velocity is what? 0. And where'd you get that from? At rest. Okay. Now, to me, good work would be to communicate that. At rest implies find or show, demonstrate that velocity is 0. And if I did that, then I did the question. I showed velocity. It was at rest. Do you agree? What about the continuity? Well, if it doesn't say, then you have two choices. You could go about trying to figure it out, or you could just say, yeah, screw it, I'm going to assume it's velocity is continuous. Now, I'm lazy, so I just say, yeah, screw it, but is velocity continuous? It is. It's not differentiable, but it is continuous. We'll talk about that all year. But velocity is continuous. And so if you aren't sure, if you know it's IVT, but it doesn't say, then I would suggest, in order for you to show the IVT part of it, just assume it is and hope it is, right? It is continuous. What about the betweenness? What did you then state for the betweenness? V equals 0 is between. Now, is it okay to say between -2 and 10? It is fine. I think better would be to say V equals 0 is between V at time 2, which is -2, and V at time 10, which is 10. That, to me, is superior work, more clear. But they're both acceptable. And after I've shown the conditions are met, I state the conclusion. Read me your conclusion, please. Somebody. IVT. There is a V or a T? A T, excellent. A T in 2 to 10. V at that time is 0. Excellent. All right. And therefore inferring at rest. You with me? This one is hard. This is a college level IVT question. Now, first of all, step back for a second. It's always easier on note day because it says IVT, use IVT, IVT, you're in IVT mode. Of course you can use it. Step back and think, this was a question on a CU exam. It was just the first Calc 1 exam. It didn't say use, there were limits, continuity, and all this stuff. So step back and think about that. Given the function, x plus sin of x, prove the function must have a real root. Now, it doesn't say, oh, first of all, change this to cosine. Sorry, this sign is a terrible problem. Cosine. X plus cosine. It doesn't say, please don't misunderstand, which is the most common error. Does not say find the root. That is not the question. And without a calculator, you're not finding the root unless you know Newton's method, which you don't. Okay? You're not going to solve this, and it doesn't ask you to. It says just prove there's got to be root. So when you think proof, your mind should say, well, I prove with IVT a lot. IVT is a proof method for some cases. It proves some things. So I'm hoping that you make that connection. What does real root imply? Like above, you need to make a little bit of a convention. What does that imply? There's a, what's root synonymous with? X-intercept for 0, exactly. X-intercept for 0, okay? So you're trying to find or demonstrate that G has to be 0. All right? The next hard part is no endpoints. They don't say negative 2, 2, 2, there's a 0. They don't say anything about that. They just say, in all the other numbers, prove it has a root. Does it have to have a 0? What's 0 between? We want between us. What's 0 between? Okay, what else? Negative, anything, and positive, anything. So if I could just find any negative point and any positive point, I'm golden. Do you agree? And this is where you start have to, this is where you have to get out of graphing calculator is all method, and you have to go into old guy method. We didn't have graphing calculators in my day. We had like an abacus. Not really. We had scientific calculators, but we had to use instead of graphing calculators, we used what's called thinking. All right. When you go to graph x plus cosine of x, you consider their parent graphs. What does y equal x look like? A line. And what does cosine look like? Sinusoid like this, yeah? Now, if you take those two parents and make a baby graph, okay, then what would it look like? What? Yeah, absolutely. What does 1 plus sine look like, or cosine? Well, that 1 is the center line. Do you agree? Shift it up 1, but 1 is the center line, and sometimes you really, I teach this in a way that I say 1 is the true root graph, and sine sometimes adds a little, sometimes subtracts a little, and it's just basically always going to stay around 1. Well, same deal here. X is the really dominant parent, whatever dominant parent you have in your family. There's my mom. But X is the dominant parent, and sine, cosine will add a little, subtract a little. So you're absolutely right. It looks like that. Now, looking at that graph, does it feel like it goes negative to positive? Absolutely. So give me, now choosing a good goals. First of all, let's talk about continuous. Is X continuous?
Yes.
All right. And what about sine?
Yes.
All right. So because X and sine are continuous, G of X is continuous. Now I'm sure there's a theorem that says that the sum of two continuous functions is continuous, but you definitely don't have to do this. Just make it up. And even if you just wrote this, that would be sufficient. Just that you know you need to have continuity. You don't have to get into the why of it. To me, that's really good math to say, get into why you say that. But this is the absolute minimum. You've got to say it's continuous at least. You with me? So now we need to talk about the betweens, and we're kind of making it up. Give me an X that you think it might be negative, and you don't have to be right. Didn't work.
Negative 20.
Negative 20. All right. Do you want to put negative 20 in a cosine?
No.
So try something else.
Negative 1.
Negative 1. Do you want to put negative 1 in a cosine?
I wasn't thinking.
Okay. What else?
Negative 5 or 2.
Now we're talking. All right. So negative pi over 2. All good guesses. Excellent. So you would have eventually said, you would have found that, in a second yourself. But so you have negative pi over 2. How does it come out? Negative pi over 2 plus 0 is negative pi over 2. Boom, we got a negative. Now what do we want? Yes.
I've got a question. So
Sure.
In the first statement, you have x and sine of x are,
Continuous, that's it.
yeah, but are we using cosine of x or sine of x?
Oh, yeah, sorry, I changed it. Yeah, absolutely right. My bad.
Okay.
Yes, thank you. 100%. It's only you're reading that, you're like, what are you talking about, son? Good call. All right, now what else? Now we need a positive. Give me a guess. Pi over 2. How does that come out? I don't need to see the work, by the way. If you just did it mentally, what is it? Pi over 2. Boom! Is what they want between those 2 points we got. Yes, we need to say that. G equals 0 is between, again, you could say negative pi over 2 and pi over 2, and it's right beneath that work, so I think they would know what you're talking about. You could do the whole G at negative pi over 2 and pi over 2 is fine. in the interest of time, I'm just gonna say g of 0 is between negative pi over 2 and pi over 2. And so can we conclude that there must be a place where g is 0? What theorem? IVT. By IVT, there is an x. Now it didn't have to say in a certain region, but where would it be? In negative pi over 2 to pi over 2, when, or where, I suppose, where g of x is, and therefore has a root. You with me? That's as hard as you'll see on a Friday. Okay? Okay, most of them are more in the AP style, they're a little easier. Let me throw some answers up here. That's tonight's homework, and if you have questions, we'll get questions. Hopefully it went well. Let's see. All right, are you ready? Do you have that out? What color is it?
I think it's yellow.
Yellow. Okay. If you already turned it in, feel free. I didn't post the answers. Sorry. So let's go. Okay. For the first row, did you get 13 by direct sub? 7/10 by direct sub?
Yes.
And 7, I guess by direct sub, but there's nowhere to sub. So it's just 7. With me?
Yes.
All right. So try and direct sub. This is end behavior. Which one dominates, log or
Bottom.
x? The bottom dominates. If the bottom goes faster, it goes to 0. That's a donut. I just started factoring with the assumption that there was something going on at 3. I found there was. It dropped out. I had 0 over 0 to start with. After dropping the whole, it was 4/5. Same on 6. I had direct substitution with 0 over 0, so I rationalized. I multiplied by the conjugate and negative 1/4. We good? Okay. 7. I also, that's end behavior, yeah. Remember, if it goes to infinity, you're talking end behavior. Those are the dominant terms. They're equal power, so it's the ratio of the coefficients, 1/10. This one, it is end behavior. It's the ratio of the coefficients. Is it 5 or root 5?
Root 5.
Root 5. This is 0 over 0, but with algebra, that 0 problem goes away, and it is 6. 10 is 0 over 0. I multiplied by the common denominator to get rid of that problem, and I arrived at 4. 11, that's not end behavior, but there is asymptote behavior. And I'm talking like, do you agree a little less than 6, this would be negative?
Yep.
And so 1 over small negative is,
Positive.
what's 1 over small negative?
Oh, negative.
Negative.
Okay.
Huge. If you put DNE, DNE is not wrong, but I would prefer negative infinity. It's more information, okay? This is asymptote on both sides. It's negative infinity, and it changes signs to positive infinity. And so I would like DNE here. You never answer with 2. So if you said plus or minus infinity, that's a no. That's not how you say it. Okay, it's DNE. Are we good? All right. Piecewise function. Figure out which piece to evaluate it at, and it's 4. Direct substitution gave me a problem. I have that this was positive infinity. I guess DNE is fine, but I would prefer infinity. This is pi, nope, this is root 3. Okay. 8. Direct substitution works there. And this approach is, what is 1 over x? Approach. As x gets large, what's 1 divided by tiny? 1 divided by huge. 0. And what is cosine of 0 approach? So that's 1. The inside approach is 0, and cosine of that 0 approach is 1. So that's a composite function, a composite function. Okay? Function is continuous if f of c exists or is defined is fine. If you wrote is defined, that's also acceptable. The limit as x goes to c of the function exists. If you just wrote limit with no argument, no f there, or f of x, please write it in. And so far, all I've said is that the points there and the approaches are there, but I also have to ensure that those are the same. So the third condition is f at c has to equal the limit and the approach have to be the same. Okay? The three types of discontinuity, what are they? Removable. What's another more layman's word for remove? Pole. What else?
Jump.
Jump. That's usually with piecewise.
Infinite.
Which is a vertical asymptote. All right. This factors into x and 2x plus 1. What's going on at x equals 0? There's a whole or removable, I'll take either. And what about at x equals negative 1 half? It's an infinite discontinuity. Does the top here have zeros? Yeah. Does the bottom have zeros, real zeros? No. And so if the bottom's never 0, then does this have any discontinuities?
None.
None. Okay, this is continuous at all. That has no issues. You could have put those together and made a super function. I kept them separate. So I said there was
MorningDublin.org. Please rise for the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
So I said there's infinite at 0 and negative 1.
Picture remake will be Friday, August 23rd and 26th for students that did not have their picture taken at registration. Live tests will be set up in the auditorium. You can have your picture taken before school, during lunch,
I
or
did
during
get into
the summer, or
continuity.
after
It
school.
was continuous at 4.
Five college visits with one stop in Greenwood Village on Sunday, September 15th with Brown, Columbia, Cornell, Rice, and University of Chicago in attendance. Must RSVP early. Staff counseling for additional information. Definitely Focus of Strength wants to remind you as we start the new school year that
What
we
about
can
X
all
equals
grow
0?
in strength. You will find the Focus of Strength wheel up around the schools. Take a minute to
Yes,
think
ma'am.
about what your sources of strength are and where you might like to grow. The purple section represents spirituality and reminds us all to do things that fill our spirit. Take a walk, spend some time outdoors.
Do you
focus on
use this
pleasant
function at x
Take
equals
some
0?
time to do whatever grounds you and feeds your spirit. Have a wonderful day.
X equals 0, you'd be on this line, and that line has 0 issues. So it is continuous at
You
all.
get to know a lot of people while having fun. You can pick up enrollment forms in the counselor's office and please return them by Friday. Don't miss out on Boys Night Night. Blast from the past. Attention all dads. This Thursday we will have a dash blast from the past.
So it's
So if you
continuous
wear
at
any
all.
old dasher, you will get candy as you enter the cafeteria at lunchtime. Don't forget to sign up for the dash. Calling all Dublin students, clubs, and sports. Interested in having your booth at the dash and earning some money and recognition for your club or sport? Contact DublinDashGroup@gmail.com for more details. But wait, there's more. This year we will have a draw for a $75 Visa gift card to be used for whatever your club sees fit. All booth requests that have been submitted by Wednesday, August 21st will be entered. Draw will be made during announcement on
That should
Thursday,
not
August
work.
22nd.
I had to find the
Dublin
limit
girls, are you interested in joining a club to make friends and hang out with other girls at school?
using the
Join
conjugate.
Elementary. Pick up mentor and mentee applications in the counseling office and be sure to turn them in by August 23rd.
Okay,
Guys, this is your opportunity to design a blended cover for the 2019
Can I move on?
student directory. In addition to the fame from having your art featured on the front of the
I'll
student
come back to
directory
that
and in the
later.
online directory app, you'll be awarded $50.
X goes to
Pick up
constant,
an
Y
entry
goes
form
to
from your art
infinity. That
teacher
is
or
it.
the front office. Deadline is Tuesday, September 3rd.
X goes to a
This is a special yearbook message for all our senior friends out there. If you did not get the superlative or activity sheet at the class meeting, please come pick one up from Mr. Dazer. They are due September 6th, along with senior pictures and baby pictures. You can turn the sheet in on Mr. Dazer. And make sure you see the yearbook tab online to get directions for submitting senior pics. We don't want to have you mandatory
people
self-esteem
find it no
quote
matter
to
what,
make sure
the
you
top
get
and bottom
some
almost
fun
cancel out, but with the sign
excellent
difference, so
review
it's, you're
Tomorrow,
going,
juniors who
think
left
numerically
station
there.
to get HK will be required to the auditorium for a Khan Academy presentation. Auditions for the fall play, I Do Like It by William Shakespeare will be at 2:45 today in the auditorium. No advanced preparation is necessary. See Miss Hannah if you have questions. The Dublin High School Society of Former Teachers next month is looking for new members who want to change the world. For more information, check our booth at the dash or contact Ms. Drew to sign up. Attention all girls going down the Boulder on North. Trials will be from 5 to 6:30 tonight. We will end at 6:30 and not 7 o'clock. Practices will be at Dublin and other locations throughout this week. We have all levels of experience to be in their welcome. For a flight. Senior dash. Friday,
Oh, I didn't think about it.
there are only 4 pairs of overalls left. Cheerleading team is Junior Pair A9. We will meet us from 3 to 7 p.m. So come on, it's convenient for you. Overalls are $25 and value pass are $10. Value pass for jewelry, self-made, fabric painting, senior bells, and much more. Secure yours now. It's time for your daily video today. Happy
Oh, man, what this?
Thank you, Mr. Richmond.
Have a great day, people. Good to see you again.
Nothing ever is no national day.
No thanks day. Oh, it's the national day.
It was censored. It's like,
Thank you. Have a good day, gentlemen. Do you guys have postcards?
they're pretty good.
Calculus? Did I give you guys calculus? You have one? The black one? Yeah. Okay, sorry, I was not. Yeah, I'll get you. Thank you.
Okay, so.
Did you get all your, how many days are you going on the first day?
The first day, first day of the month,
Oh, so we missed each other. I don't know you.
Yeah.
That's why. Okay, cool. Just take this with you and get that to me tomorrow, okay?
Okay.
Should be easy. It's pretty